Janak Kanade, are you there?
Yes, sir.
So you can share your slides.
Yeah, sure. Is it visible?
Yes, it is visible.
Okay. Can we start the presentation?
Yes, we can start.
Okay, so I along with my team member Omkar Jagtap will be presenting today. So
Yes,
Omkar,
yes, yes.
Yes. Hello, sir.
Yeah,
Yes. Good afternoon, sir. We, the students of Vishwakarma Institute of Technology,
right,
we are going to present our topic, which is design and analysis of experiments in intercity bus transport system. Next.
right, right.
So these are the contents of our presentation. Next. Let us see what is the problem statement, then domain, scope, and objectives in brief. So the problem statement is design and analysis of experiments in intercity bus transport system in Maharashtra state. So basically, we try to differentiate the quality of service provided by intercity bus transport service providers in Maharashtra. So that is MSRTC and the private bus owners. So the domain is service sector, and in that quality analysis is what we have done. The scope is that according to official website of MSRTC, on daily basis around 6.7 million people use the service. So the domain is the scope is very wide. The need of the project was that after survey and even before that we found that uh, the comfort on seats, then management inefficiencies, lack of cleanliness, and so on were the issues. So we wanted to suggest these service providers some measures so that they can improve upon their quality of service. And objectives were basically to uh, help them improve their service quality and making this study more customer oriented. Next.
Omkar, how could
Yes.
you relate this research work to energy management?
uh, yes, sir. So that, sir, when we started this study, we were not actually keeping in mind energy, but through our study, we sort of had to take it into consideration and relating that. We'll show, sir, how we were able to relate that to energy management in our conclusions.
Okay,
Yes, sir.
fine, fine.
This is the literature review in brief. The important research papers only have been mentioned. Others are in detail given in the paper. So the paper one was about use of DOE, that is design of experiments. The second one was about use of DOE in non-manufacturing, because doing design of experiments in manufacturing is quite easy, but since ours is a service sector, it is quite challenging. In fact, it was the most challenging part of this study. Then part paper number three was about a guide uh, for the DOE in transportation sector in particular. Then paper number four was about performing surveys, and fifth was about taking online surveys. Next. Uh, so let us see what is the first stage of our study, and that was finding out CTQs. CTQ stands for critical to quality factors. So as far as the transportation sector is concerned, uh, based on literature review, these seven given in the figure number one, these are the uh, quality factors. Sorry, I'm not able to see.
Hello.
Just. Uh, these are the seven factors, that is comfort, pricing, stability, information, accessibility, support, and safety. So based on these, the quality of service is decided. Now on the right hand side, the figure number two, we can see a kind of table, but it is called as quality function deployment, which is a kind of statistical tool in this statistics. And now
Have
basically
you
we
have you have you taken a survey, Omkar?
yes sir, yes, based on that only we have done this.
Okay,
And then based on that QFD, then we found that three parameters or factors were most important as per the uh, consumers or the consumers of the service or the passengers. These were safety, pricing, and comfort. So safety being ranked highest, then pricing, and then comfort. Next. So let us see how we perform DOE. So DOE as a method helped us design our survey comprehensively, as there were multiple factors. So here we can see there are three factors most important, and there were two levels. So basically number of experiments to be done were 8. So for example, we would be asking people, what if what is the quality of service as percepted by you if pricing is low, comfort is average, and safety is excellent, and so on. So this was the second stage. But then how the people will get to know that what is good and what is bad, or what is good safety and what is bad safety. So again here different papers helped us, and we found that if uh, good safety as a parameter is to be taken into consideration, then it has to have certain factors. For example, having CCTVs, then emergency exit, automatic door locking system.
Hello. Hello.
Omkar,
Sir,
you are not audible.
so, sir, shall I continue?
Yes.
Okay.
Yeah.
Hello.
So, yes, Omkar, I'll
I think
continue. So,
someone muted me, I guess.
uh,
Okay. Okay,
Omkar,
then
can I continue?
no, I can.
Okay, sure.
Okay, so survey design was the next stage. So we had performed this in two ways, that is personally administered as well as the online surveys. Online survey was done through Google Form. Now, input parameters taken from the people where email ID, age group, and gender, city, mode of bus they usually use for transport, and then type of bus that they will suggest in general. And we can see in the figure number 6 that how we actually did this. So let's see one question: how satisfied will you be with the bus travel if tickets are cheap, journey is uncomfortable, and journey is safe? And what does it mean? That is like what is mean by journey is uncomfortable? That was also mentioned in the brackets, and then they had to give a rating from 1 to 10, 10 being the best. Next.
Yeah, so Omkar up until now explained how we were dealing with the design of experiment parts and how we undertook the survey. So, as per the question that was showed in the previous slide, we undertook the same study for about 408 or greater than 400 surveys were undertaken. And at this point, we had data for each of the 8 experimental conditions. So now we wanted to analyze it and give it a perspective to finally create a mathematical model which can tell us that overall in the transportation sector, what are the factors and how are they affecting the overall customer satisfaction. So to that, do that first.
Janak, have you used any software tool like SPSS
Yes,
or
sir.
something?
We used Minitab.
Okay,
Minitab 19.
right.
So the first step in that was data screening because it was a survey based study. There were bound to be a lot of false entries, and so the first stage in that was a manual data screening where we manually identified the wrong entries, and the second stage was we statistically tried to filter out the data using box plot and control chart. So that was also done in Minitab. And post that, then we were able to find out average values for each of the 8 treatment conditions, and then we entered those values using the graphical summary into the Minitab software. So now with this we had 8 experimental treatment conditions and one associated value to each of them, output value, which will be customer satisfaction. So now we had to create a mathematical model with that. So before finally conducting the mathematical model, first few things that we wanted to look for is the experiment valid or is DOE possible for this data. So again in Minitab using analysis of factorial design tool we did that, and one of the outputs that it involved was the Pareto of standardized defects. So over here we were able to see that there were some significant defects and therefore this experiment was fit. However, one point that was there that this was not the perfect model with all the factors under consideration, because we can see that there are still some factors insignificant. So we had to do manual permutations, and this was the part where we had to do the technical study and take into aspect all the factors to decide which combination of effects should we take to finally consider or construct the model. And through permutation and combination of selecting those factors, we were able to land down on these 4 effects. And as we can see over here, this is the model for those 4 effects. And this decision was primarily taken based on the statistical analysis. For example, analysis of residuals, or how are the residuals? Are they normally distributed? Are they sufficiently random? Or what is the R square value? So using this model was finalized, and this was the main technical part of the study where we had to do significant amount of combinations. So,
Janak, Janak, one
yes, sir.
question is that you have used 19 references, okay, for your paper.
Yes, sir.
Have you compared or matched the outcome of your research with those references?
Sir, what we did was, because this was a bit different, the way we matched it was using when we wanted to validate it. So we had a previous research paper
Okay.
that was presented by us only, and in that we had collected a data in a different manner. So we ran a simulation to that, and the results of the previous study were compared to the results of this study,
Okay. Okay.
and,
Please
and
continue.
that's how we tried to validate it.
Good. Good. Please continue.
Yes, sir. So this with this model constructed, we were able to now in a sufficient place to analyze what exactly are there. And in order to do that, the first step we taken was analyze the main effects and interactions of the factors. So the main effect plot sort of was a validating tool, because it gave us that yes, with comfort, as comfort and safety increases, the satisfaction increases, and as pricing increases, satisfaction decreases. However, some inferences were that, for example, the slope of safety is much more greater than as compared to that of pricing and comfort. Therefore, it must be more critical as compared to both of them, or comfort is more critical as compared to pricing. And the second part of inferences or analysis was involved in the interaction plots. So where we could, in combination, for example, what is the combined effect of safety and comfort, and how does it affect the customer satisfaction? And this helped us derive inferences like, for example, cheap tickets with good comfort and without a considerable amount of safety will have no value on the customer satisfaction, and also help us identify factors such as value for money. However, coming to the concluding part, so this helped us make certain inferences about the customer behavior and how these factors affected the customer satisfaction. But one of the final goals was to construct a mathematical model which can enable us to predict up to some extent a certain satisfaction level. And in order to do that, with the help of the model, we use the response optimizer tool in the Minitab itself and try to simulate this particular concept based on the same model. So this was it. So first aspect was is that given a certain combination of pricing, comfort, and safety, it can predict the value of Y, which is the customer satisfaction, and vice versa. With a certain target level of satisfaction, we can determine what should be the level of a particular factor. So now, before concluding, to be honest, when we started this entire study, we had never considered in mind about anything about environment, energy, or even climate change. But eventually, what we realized through our surveys and in our end study, that when we were dealing with particularly the comfort aspect, the way in which we had defined comfort, and also what we realized through our personally administered surveys was there was a greater inclination towards best comfort when it came to electric vehicles. And even in the way in which we had defined the comfort factor, with the new electric vehicle and electric buses available, they will have the best comfort rating, or the 5 comfort rating. So because of this, customer perception of comfort is associated with electrical vehicles. And if this holds true, then in order to increase satisfaction, one will have to increase comfort, and eventually with this consensus, it will be in such a way that the electrification of all the transport vehicles will increase the comfort, which will in turn increase the satisfaction. So this will not, and this will eventually, of course, affect the carbon footprint. So the point that we inferred and what we are trying to make is that even in the aspect of quality, where now most of the things that we are considering, for example, the CTQ parameters that we considered, for example, safety, pricing, comfort, and all others were a bit generalized. But if we are to drill down further into this study and consider it in a much more solid manner, then this factor will not be mandated just by government laws or rules, for example, this environment and climate change, but it will be a important CTQ in itself to be defined, and this will need to be identified even by the operators of these companies, because if such a significant amount of inference related to environmental awareness is associated with each and every customer with the increasing awareness, then the same awareness and the significance will need to be given by the operators of these buses also. And this will in turn also have a cascaded effect on the carbon emissions of that these buses. For example, when we were trying to conclude the study, we just tried to refer to the data of the MSRTC buses, and it was said that each bus averages around 5 kilometers per liter for diesel, and 1 liter of diesel emits 2.5 kgs of carbon. And if we consider only in between Pune to Mumbai, there are around 200 buses operating on some or the other routes. So in Pune to Mumbai itself, daily, if we consider the transport, then it will be in thousands of kgs of carbon emission. So in proceeding,
But the cost of electric buses are more than the
yes, sir. So now that can be proven by simulation, because as we can see over here, the slope of pricing is very less. So the increasing satisfaction that will be shown by the increasing comfort and safety will be insignificant as compared to the decrease in satisfaction with respect to pricing, because increasing comfort will have a much more increasing customer satisfaction. So that will be more than no doubt.
right. Thank you, Omkar. Thank you, Janak.
Thank you, sir.
It was a really good presentation.
Thank
Okay.
you, sir. Thank you so much.
The next speaker is Krishna Katta.
Very good afternoon, sir.
Hello, sir.
Yes, Radhika.
Actually, I am exchanging with Krishna Katta, sir.
Sure, no problem.
Thank you, sir.
Radhika,
Yes, sir. Yes.
this presentation is being recorded, so kindly try to make it a perfect one. Okay.
Okay, sir. Screen share. 1 minute, sir. Screen share. Sir, 1 minute, sir. My screen sharing is not
No
coming.
problem.
Sanya madam. Sanya madam.
Radhika?
Minute, sir. Sorry, sir.
Radhika, can you speak for 10 minutes on the
Sir,
topic?
Yes, sir, sir. 1 minute, sir. My screen is not showing, so that here the problem is there. So it's I searching, sir. షేర్లోనే ఉంది ఇది ఇక్కడ స్క్రీన్ డెస్క్టాప్ మీద డెస్క్టాప్
You are not audible. Please unmute yourself.
Hello, sir.
Yes. Yes.
Meanwhile, can you guide them how to share the screen? Even the same problem maybe occurs for us.
I don't think it is any. There is any difficulty. Radhika, please unmute yourself. Yes, you're audible.
not some difficulty is this. Sir, sure. How it shares, sir?
Yeah, you can speak.
Sir, how it shares, sir? It is not coming, sir.
No, no problem. You can speak for 5 minutes.
P- Sir, the PPT is visible, sir.
No, it is not visible.
Not visible at all. 1 minute, sir. Sir, just should discuss with my colleague. Hello?
Yes.
Sir, is it not visible, sir?
No, it is not visible.
1 minute, sir.
Okay, you can do one thing.
Sir,
I'm allowing the next speaker. You can try yourself, and later on you can join. Sarita Kumari, are you there? Sarita Kumari,
Hello?
are you ready to present?
Hello, Amshi. Huh?
Sarita Kumari, Krishna Katta,
Hello, sir.
you can continue with your presentation.
It's okay for me. Give me a second, like I will share my screen. Can you see my presentation, sir?
No, it is not coming. It is not visible actually.
Now? There is difficulty with sharing screens actually. I don't know.
It is coming.
This is Radhika's, I think.
Yes, there is no difficulty, no.
వినిపిస్తుంది సార్ హలో
Yes,
సార్ 1 minute sir. Good
it is visible. It is visible.
Okay, thank you, sir. Sorry, sir, for the
No
distribution.
problem.
Actually, it is not coming, so that's why I did have help my colleagues. Sir, actually, here this is Radhika. I'm
Okay.
a research scholar, the PhD part-time under the guidance of Professor Balaji Rao, sir, Geetam University, Hyderabad.
Right.
My research topic is the material science. Here, my title of the work is the efficiency of the preparation of the cathode materials on sodium ion batteries. This one is the outline of my presentation. What is the introduction, the problem to take, which type of the literature papers I can use it for the preparation of the samples and for the result purpose, and what is the research methodology using for the preparation of the samples, and finally, what is the characterizations and results and discussions. So here this is about the battery. So introduction to battery here. How is the battery and what is the battery? How many components of the battery is there? How the battery is working? The battery is nothing but a transducer here which converts the chemical energy to electrical energy, and it contains also the electrodes and electrolytes. Here, cathode. Electrodes are the two types. One is cathode and anode. What is cathode? Cathode is nothing but the positive terminal, and it is the reduction. Reduction takes place. The reduction is nothing but the gain of electrons. And the second one is anode. Anode is nothing but the negative terminal. Oxidation takes place. Oxidation nothing but the loss of electrons. And the third one is electrolyte. It is the one of the layer between the cathode and anode. Here the ions are transferred from the anode to cathode, that is the battery is the charging, and the electrons are moving from the cathode to anode, that is the battery is the discharging is there. So now here my theme is the preparation of the cathode metals for the sodium ion batteries only. Before the lithium ion batteries is also there. Why we can using the sodium ion batteries for the lithium ion batteries?
Radhika,
Yes, sir.
is it possible to fabricate sodium ion batteries? Have you heard about this manufactured by somebody or in some countries?
Sir, yes, sir, yes, sir.
It is feasible, or it is a hypothetical idea created by you?
It is also feasible, sir. Why? Because so present here running is also
Okay.
number of the papers are also published according to sodium and batteries.
Okay.
Here the why we can using the sodium ion batteries compared to the lithium ion batteries means the sodium ion batteries at the weight is the very less compared to the lithium ion batteries, and the cost is very also cheap compared to the lithium ion batteries. So here the sodium ion batteries is also having the same chemical characterization like the lithium ion batteries. So the same and conductivities and energy density is also high. So that's why I chose the sodium ion batteries. Why? Because it is the cost is very low. So that's why I'm using the sodium ion batteries for further generation for the smart grid applications. Okay. Here, this is the graph took from the literature survey here. What are the different types of the cathode materials? So there are the different types of the cathode materials are the layered oxide materials and polyanion materials. My work is on polyanion materials. So in layered oxide materials, they are the O3 type and P2 type. So here O3 type having the structure is the octahedral structure, and the P2 type compounds are having the prismatic sign. Here the polyiron matrix having the my in my work the orthorhombic structure is also coming there. Why you can using the polyiron matrix means the polyiron compounds are the very stability. The cathode metals are high stability, safety, and suitable for the operating. And these are the different parts that they're borates, phosphates, pyrophosphates. So that's why I choose the polyiron means more than the number of ions. So that's why I choose the polyiron materials for the preparation of the cathode materials. So number of the papers for the taken for the literation purpose. Here, this is also the graph from the literature review. So by combination of these sodium, vanadium, phosphate, and chlorine, and these combinations having the high energy density, high theoretical capacity, and high voltage. So that's why for the increasing of the better characterization, I add the nickel extra to these elements. So that's why the my conductivity is also increases in further. So the type of the work is also completed in my work. So and also from the literature survey here, you observe here this one, the voltage is taken from the 2 volts to 4 volts in case of the charging, and discharging is also takes from the 4 to 2 volts up to the sum of the particular voltage here. This is the saturation point is also coming there, and what are the by varying of the different C rates, how the specific capacity is also decreases by increasing of the cycle numbers, and what is the final efficiency value. So this type of the graph is also calculated in my graph. Yeah, these are the graphs in our group. My Geetam University is also completed here in this one in previous. So these are the different chemical characterization and electrochemical characterization is also taken, and what are the impedance graph is also coming there. So from this one, my problem is starting here. I took the polyanion problem. The present one, the first work is come to you can take. I took the combination of the sodium, nickel, and vanadium phosphates. Here, the X value is varying from the point 0.1 to 0.5. So for the three samples, I completed the different calculations is also there. Here, what is the research methodology? For the preparation of the samples, I selected the melt pinching technique. And after completion of the melt pinching, the glass preparation is also coming there after the electrochemical tests are completed. So what is the research? Which type of the research methodology is used? Though these are the raw materials. These raw materials are taken in a agate motor, and it is the completely converted into the up to the 1 hour the coming the small polycrystals it is also completed coming to the powder. So after this powder is taken in some of the crucible, it is heated up to the 1200 degrees centigrade in the furnace nearly 1000 degrees and not 1200. So after that one, these are the powder is also melted. After this melting is converted into the quench. This is the poured on a glass plate. The glass is also formed. This glass is also quenched at room temperature. By taking of the glass is also taking in a ball milling up to the 250 rpm is taken every 3 seconds one rotation, and also after 3 seconds it takes the rest. After 3 seconds, sir, 3 minutes. So every 3 minutes the one rotation is completed. Up to the nearly 30 to 50 hours it comes to the nano glass powder is also coming there. The same nano glass powder is taking then for further studies of the calibration techniques. So these are the my nickel samples. This the x is equal to zero point 0.1 and zero point 0.3 and zero point 0.5. Here coming of the physical property of these samples, I observed the zero point 0.3 sample is also transparent compared to the remaining sample. So that's why the same in further my studies also for the zero point 0.3 is the best one. Why? Because here this one having the better values compared to the other samples. So coming to the capture here, these are the capturation techniques also. One is DTA. Here the DTA is nothing but the differential thermal analysis. So here in differential thermal analysis, by taking of the temperature, I observed all the three samples for the TZ, TC and TM. Here the dotted lines indicates the glass and the solid lines indicates the glass ceramic. So by using of the TZ and TC values, I calculate the delta T value. Here the what is the delta is nothing but the glass ability parameter, and KZL value. KZL value is the Herbies parameter at which the KZL value is nearly equal to 0.53, 0.5, then that sample is nothing but the best sample. Here you can observe at the best sample the TG value is the very low and the remaining values are the high. And also after the glass sample, the glass powder is heated up to the 5 hours, the glasses are converted to the glass ceramics. So the best sample glass ceramic having the values decreases from zero point 0.5 to zero point 0.3. So according to my values, the which the zero point 0.5 values is also the best sample and 0.35 is the best sample for in glass ceramics by taking of the ETA analysis. So here after that one, the X-ray diffraction calculation technique. Here in this one Xrd you can observe the what is the size of the crystal size and what is the crystal structure is also identified, and how many different types of the phases is also coming there. From expert high score analyzed, these are the graphs, Williamson Hall graphs is also coming there. By using this one, you can identify what is the size and strain of the sample is also coming there. So these are the different phases are also coming in my samples. You can observe this zero point 0.3 sample having the small crystalline peaks is also compared to the remaining. So that's why this is having the amorphous nature in XRD techniques. So by taking off the lattice parameter values and the angles, the final my all the samples are having the orthorhombic structure. So the orthorhombic structure, the lattice parameter range value is A not equal to B not equal to C. The three values are the different. The same is observing in my observations also. So this is you can identify the structure is also coming from the XRD analysis. Next, what is the SEM analysis? Scanning electron microscope. Here the pure the inlet figure, the pure is indicates the glass samples and the remaining background of the figure is indicates the glass ceramics. This one is the zero point 0.1 and zero point 0.3 and zero point 0.5, and when x equal to zero point 0.3 samples, the background having the number of the crystal grains is also formed. So that's why this is the better one compared to the remaining. From the SEM analysis, you can identify the morphology of the crystal is also identified from the SEM analysis. And the next one is this is nothing but the one of the Nyquist graphs is also coming there. The Nyquist is nothing but here in this you can measure the real impedance value is taken, real impedance value is taken along x-axis and imaginary value is taken along the y-axis from the Nyquist graphs. So which sample having the lowest semicircular path is coming here, nothing but the lower resistivity is a reversible of the conductivity. So that's why the zero point 0.3 sample having the high conductivity is also coming there in my samples. And also can calculate the bulk conductivity is also calculated from these samples. And after that, these are the from this one the electrochemical analysis are also coming there. So these are the electrochemical analysis for the charge and discharging of my samples. the point 1, point 10, point 5. Then I can observe the what is the charging and discharging values of the first cycle and the 20th cycle. So by using of these values, you can observe this graph is also coming. What is the first discharging capacity from this above graph, and what is the first discharging capacity for zero point 0.3 samples and point 0.1 and point 0.5. This is the discharge and this is the charge. And taking the difference of these values, you can identify the what is the capacity value is also coming there in first cycle. Similarly, what is the capacity is also coming there in 20th cycle. So finally, you can identify what is the efficiency is coming there in my samples. Here the zero point 0.3 sample having the highest efficiency is also coming there, and remaining samples having the lowest efficiency. So that's why according to the efficiencies also you can say about I'm completely saying about this is nothing but one of the my best sample in my all about the three samples. Here this one is the same charging and discharging graphs, but here the C rate is also increases from zero point 0.1 to 10 C rate. The C rate is increases, then the charging is also here decreases. So that's why these are the different C rates, the charging and discharging graphs of the all three samples. Here in this one is the from coming of the previous values, I know about the 0.3 sample is nothing but the best sample. So that's why the same sample is taking by increasing of the cycles nearly from the first cycle to the 20th cycle. So according to that one, so you can calculate it what is the charging values and what is the discharging value, how many types of the retention discharging value is also coming there in my samples. And also here the cycle number is also increases from the 0 to 50. Then what is the discharging capacity is also coming here from the zero point 0.1 sample and zero point 0.3 and the zero point 0.5 samples. So from these figures you can measure this table is also what is the final conductivity is also coming there. Here this one is also high conductivity is compared to the remaining one. So that's why I can say about this is the best sample of all these samples. And these are the final the total what is the final conclusion of this one. Here the first figure is also explain about the what is the C rate, what is the probability discharge capacities of all three samples by varying of the C rates, and how much discharge capacity is also coming there by varying of the different C rates from the zero point 0.1 C rate to 10 C rate. And here from the second figure, here we can increasing of the cycles up to the 50 cycles. Then from zero point 0.1 C rate to 10 C rate, the discharge is also capacity is decreases. Again, the C rate is also coming to the first C rate. The again some of the graph is also variation is also coming there. So finally out of this one, this is the best one. And also the same best sample is also taking of the impedance values for the up to the 100 cycles. Here the black one it is also 100 cycles. So up to the 100 cycles, at 100 cycles, you can getting the lowest resistivity. So that's why the high conductivity is also coming there in my samples. And also the same zero point 0.3 sample is also here. The red line also indicates for the zero point 0.3 samples. You can identify the finally, this is the anodic value and this is the cathodic value. Nothing but the charging value is also coming there 2.35 volts, but the remaining values are the lower values compared to the 2.35 volts. And the discharging values are also coming from 1.8. And here the sodiation and desodiation is also coming there in anodic and cathodic properties. So for that one, the highest voltage value is also charging and discharging coming there in zero point 0.3 sample is also. That's why this is the one of the better sample for the preparation of the cathode materials. The final conclusion is here the first one is so from the DTA analysis, the which value delta is the high value and which the KGL value is the low value, then that is the better samples compared to the remaining samples. From the Xrd is also identify the different the crystal phases. So from that one, I identify my structure is the orthorhombic structure, which is having the most stable structure compared to the remaining one. And from the SEM analysis, we can using the Debye-Scherrer equation, the zero point 0.9 lambda by d is equal to k lambda by beta sine theta. Here the k is nothing but the strain of the value, and it is found to between the value is the 100 to 350 nanometers. So my sample is nearly nearly range between these nanometers values, and also some of the grains is also coming there in my same analysis. From this one also the when the sodium ions are replaced by the vanadium, so that's why my structure is also very stable compared to the remaining one. So for these type of the structure, the polyanion cathode materials are very suitable for the preparation of the sodium matrix for the smart grid applications. Thank you, sir.
Are you working alone on this project or there is a group of people?
Sir?
Are you working alone on this project?
Yes, sir. One minute. 1 minute, sir.
Radhika,
Sir.
is it possible to fabricate sodium ion batteries practically?
Possible, sir.
Is it there in commercially available somewhere in any other countries?
My scholar is also preparing for the Vamsi Krishna is also prepared for the full cell batteries, sir.
Okay, okay. So you are working alone on this project?
My mine is preparation of cathode, sir.
Okay.
Mine is preparation of only cathode.
Thank you, Radhika.
Sir, sorry, sir, for the presentation. Some of the distribution is there.
No problem. Such things happen, Radhika.
Thank you, sir. My friend is also
Okay,
failed. Sarita Kumar.
okay.
Good evening, sir.
Good evening, Sarita.
Good evening, sir.
So in which topic you are going to speak? Your paper title is NABIGE Glass Anode as a High Performance Network.
Yes, sir.
Sir.
Yeah, it is visible.
Okay, sir.
You
So,
can
good
continue.
evening, everyone. This is Sarita Kumarari under the guidance of Professor R. Balaji Ragararu. So, I am the research scholar, part-time Department of Physics, Geetham School of Science. So let us discussing about the introduction about for the battery literature survey, problem statement, research design, methodology, result and discussions, conclusion. Now coming to the introduction for our battery. Battery is a device which converts chemical energy to contained with its active material directly electrical energy by means of electrochemical principle of battery device which stores the chemical energy to electrical energy. So that means the electrons flow of electrons from one material to another material throughout an external circuit. Then flow of electrons provide a electric current can be used to do work. uh, Lithium and sodium ion batteries. Sodium ion is a very best material. Why? Because it is a friendly, environmental, easily manufacturing and low cost compared to the lithium ion batteries are becoming now. Next, the batteries are three compounds: anode, cathode, and electrolyte. Anode is a negative terminal, cathode is a positive, electrolyte is separation between the two materials. Now, uh, the role of an anode sodium ion batteries. The anode is a negative, releasing of electron to the electronal circuit and oxidation during the electrochemical reaction. The negative pole is during the discharge. Electrochemical negative pole is during the discharging and positive pole is during a charge condition. The components of anode materials, different kinds of materials, carbanoids, metal alloys, metal oxides. Carbanoids, example, graphite structure. For the graphite is hexagonal structure. Metal oxides are examples are germanium, titanium oxides. The crystalline structures are octahedral and tetrahedral inside. Metal alloys are with the nickel, steel, copper, etc. They are having to the cubic structures like a BCC and the FCC structures. According to this role of anode in sodium ion batteries, from the various group of sodium ion batteries, these are the literature surveys of different papers. My work is glass and glass ceramic anode prepared. Effect of germanium oxide nanocrystals on sodium ion storage capacity of sodium bismuth glass anode network. So this is the raw material. That is the problem solution. 100 minus 6 into 35 Na2O 65 Bi2O3 X germanium oxide. Here taken X values are investigated at the 5 samples from 0 to 10 mole percent. So this is the synthesization of the my compound milling process. Milling process is nothing but the investigation ball milling technique method. So here the inside of the instrument some iron coils are there. The iron coils are having to the 250 RPM. So the machinery movement of the disc is depending upon the centrifugal force. So filled that the chemicals depends upon the milling times. So we collect the milling time is increases. So collect the powder, fill that crucible, we apply the calcination. Calcination is nothing but the high temperature. After collect the samples, pelletization. After that pelletization, collect the pellets, sintering of pellets. Sintering is nothing but the treatment. Heat treatment up to 700 to 800 degrees centigrade. Final resulting pellets are there. So each pellet size is 10 millimeters. So this is the synthesizer compound. So our laboratory ball milling techniques, this is for sample. So my prepare samples like this milling, calcination, resulting of pellets, filtering pellets. Characterization, go for characterizations, XRD, SEM, DTA, electrochemical studies, life cycle analysis, impedance spectroscopy. Now go for the Xrd profile. Here, by using this sample, the milling time will be increases. The crystalline size is gradually decreases from 200 nanometers to 3 nanometers. After 35 milling time, the crystalline size will be increases. So from this profile, at a 0 hours time milling time, I noticed some peak values. So gradually increases time 10 hours, 20 hours, 30 hours. The sample completely it becomes to a amorphous nature. So this is the XRD profile. Now coming to the life cycle analysis, the cycles will be increases, the capacitance is gradually decreases for all the samples 0 to 10 mole percentage. So different sample is having to the different capacity values. So that capacity values are like this. The first of all we take the first charge and first discharge capacitance values are taken all the samples. After the differences between these two samples we calculate the capacitance loss. So after by using the capacitance loss and charge capacity, we calculate the Coulombic efficiency for all the samples. Here I noticed that fifth sample is having to the high Coulombic efficiency. Similarly calculated the 500 cycle capacitance charge and discharge and Coulombic efficiency values. Here also the fifth sample is having to the high Coulombic efficiency. So this is for charge discharge curves. Now here the first sample, we take the first sample different cycles. First 10, 50, 100, 250, 500 cycles charge and discharge curves like this. So from this graph, I calculated the Coulombic efficiency. First cycle 10, 50, 100, 250, 500 per best sample, capacity, discharge capacity, loss and Coulombic efficiency. So here I noticed that the first sample, fifth sample is having to the high capacity and the high Coulombic efficiency. That's why I go for the Xrd profile at 30 hours small milling time, different charge discharge cycles. Here the first charge, first discharge, fifth charge and fifth discharge. So first charge, first discharge, fifth charge and discharge, I noticed the some peaks values. So first charge and fifth charge noticed the sodium germanium and sodium bismuth plane peaks are observed. Similarly, in discharge cases also observed the bismuth oxide and germanium oxides. So I noticed this. Here the TEM images. By using the TEM images, my sample is having to the morphology. Morphology means it can explain the formation of the crystalline structure. So and finally can find out the Miller indices, ABC values and HKL values also find out from the TEM images. After go for DRD profile. DTA profile, differential thermal analysis profile, take the different cycles, first cycle, 25th and 5th cycle for the best sample. I noticed the glass transition temperature and crystallization temperatures. So here glass transition first cycle 636 and the crystallization 882 degrees centigrade. This gradually decreases, increasing the cycles. After that, I calculated from glass transition temperature and crystallization temperature, calculate the stability of the samples for a best sample NBG5 sample. After that, calculated the different C rates, increasing the C rate and the cycle number will be increases, the capacity is gradually decreases. Correspondingly, the Coulombic efficiency also calculated. It is also having to the increasing and the some it will be stable condition. That is the rate performance and the efficiency of the best glass anode material in different C rates. So this is the impedance. Here Nyquist curves are formed. So which one is having to the semicircle width will be decreases. That one is the best sample for a different cycles. Fifth 100, 50 and 10 cycles of the impedance curves, Nyquist curves. So after that we take the CV, voltammetric, cyclic voltograph. Here the anodic and cathodic nature. Charge condition is having to the 1.0 volts and the discharge condition 0.03 volts. I noticed that best sample different cycles it is having to the decidization and sodization process. So finally conclusion, I noticed that my sample is having to the high capacity and good Coulombic efficiency at 1.12 volts per first cycle, 1.0 volts per 100 cycles due to the preparation of amorphous of high structural domains. Thank you, sir.
It was a nice presentation,
Thank you.
Sarita, and your presentation contains so many experimental results. So it was very, you can say, heartening to see so many experimental results and very well presented by you. Right?
Thank you, sir.
Thank you, Sarita.
Thank you, ma'am.
Next is
Thank you, sir. Thank you very much.
Thank you very much.
Kiran Kumar. Kiran Kumar, are you there?
నువ్వు ఇలా చెప్పేసరికి అదంటే ఈ అనిపిస్తుందంట వంశీకి ఫాస్ట్ చెప్పట్లేదు
Kiran Kumar. Krishna Gatta, are you there?
Hello, sir.
Yeah, you can start your presentation.
Okay. Let me share screen. Can you see this, sir? Can you see my
Yes,
screen?
yes, it is visible.
First of all, thank you so much for giving this opportunity, sir.
Right.
Um, so let me start from the first. So my research area is on material science.
Okay.
So I'm doing my thesis on sodium-ion batteries.
So thesis means, are you a master's degree student or PhD student?
I'm PhD student, sir.
Okay, great. Very good.
Yeah, thank you so much. So my work is on sodium-ion batteries. So you have raised a question that before some Radhika ma'am is saying about sodium-ion batteries, you have raised a question that how the sodium-ion is possible. Is it hypothetical or is it possible in reality?
Yes.
So just I want to say a small note on this. Yeah, sir, definitely the sodium ion is possible, and in India also, like some industries has developed sodium ion batteries. Soon, like by 2023 Jan, you can see commercialized sodium ion batteries, sir. Even like companies like Indie and Godi, like such sodium ion manufacturing industries are also available now. Okay. Why sodium ion batteries we are taken means like it is just similar to the lithium ion battery, sir.
Okay.
The principle what is happening in the lithium ion battery is quite similar. Is same thing is happening in sodium ion batteries. Maybe there is a different technique used in lead acid battery, but the entire principle, entire thing was same in both lithium and sodium batteries. But so a country like India, we definitely see the cost, definite manufacturing cost, all these things. So when compared to these three batteries, sodium ion battery has low cost, high density, high safe. We have seen electrical vehicles are catching fires and all these things. I will say what is the reason of these things also like later. It is highly stable and high safety and efficiency, sir. So to overcome drawbacks of this lithium ion and lead acid batteries, we are choosing sodium ion batteries, sir. Okay, I have went through different literatures um, from my group and different various groups all over the globe, and I have find some gaps in this battery technology. Actually, to design a complete battery, we need anode, cathode, and electrolyte, sir. So that three things we are developing here. But this presentation I am saying about anode materials. Okay. So for lithium-ion batteries, graphite is a perfect anode material. Like now, commercially, we are using lithium-ion batteries in our gauges. So in that, this graphite is acting as an anode material in that lithium-ion batteries. So while coming to if you implement the same thing for sodium ion, but graphene has some disadvantages, and hard carbon is suitable for the sodium ion batteries for anode metal. Why it means like the layer between these two is very small, sir, for graphene, but in hard carbon it is wide. The size of the sodium is large one compared to the lithium. That is the major drawback of the sodium ion batteries. Its mass is high, its size of the sodium is high. That is a major drawback. So having good, poor electrical conductivity actually for the sodiums when compared to
Krishna,
lithium. Sir,
if there is so much advantage in sodium ion battery, then why the whole world is
huh.
going after the
Yeah,
lithium ion?
I will let you.
Okay.
So to store the energy, what is the major condition, sir? We need high conductivity. Apart from cost, all these things, even it is cheap, or even it is safety, but conductivity also a major important. We can produce high conductivity, means that we can avoid that gaps. But sodium has pure electrical conductivity, sir. Why? Because sodium the mass of the sodium is very large. It has 11 electrons. Its atomic number is 11. So the diffusion of a sodium from cathode to anode, it takes like we know generally we can say small people, like a thin guy can run fast than a fat guy. The same thing is happening with sodium and lithium, sir. Lithium can produce high conductivity because it is small. Sodium is quite large when compared to lithium, so it cannot produce that much conductivity. That is the only drawback that sodium is facing. So this is happening due to this anode has graphene and hard carbon. But when compared to hard carbon, graphene hard carbon is better. But our principle is that we don't want to go for again carbon based materials, which is environment issues. There we already coming out from the fossil fuels because we should clean our environment. Again, I don't want to go for this carbon type materials. So alternative to this carbon type materials is amorphous materials, sir. So why amorphous materials? I already told you that sodium has a drawback of its size. So if you chosen the amorphous material, it has short range, sir, and open network and high there is a path to for the diffusion in the amorphous materials, while compared to crystal materials, crystal materials are closely packed, so sodium cannot get a chance to move from cathode to anode or any diffusions and intercalations. But coming to the amorphous materials, there is a lot of huge gaps in even the size is large. They can accommodate, they can intercalate the sodium material in that surface because of its short range. That's why we are choosing this amorphous material, sir. So from these things, I have derived myself a few objects for my thesis. That is, I need to design a good high density non-flammable, which is currently big burden to the batteries, non-flammable and cycle stable anode materials. And apart from this, I need to go for low cost anode sodium ion batteries too. These are the two objectives that I was taken. So in that frame, I was designed my thesis, and among them, this is one of paper. So large scale electrochemical stability voltage for sodium vanadate, zinc oxide, glass and glass ceramic materials, glass ceramic anode. So I have chosen sodium and vanadium because it has good glass networks. Vanadium can easily form a good amorphous background network. So so that I have chosen this sodium vanadate. I was told you that sodium is lacking of conductivity. So to boost that conductivity, I have chosen sodium zinc oxide nanoparticles. I have doped that nanoparticles in the glass network to boost that network. So coming to my research design, here I have taken raw materials. However, our recent Sarita ma'am has explained the process as well. Melt quenching, I have melted my raw materials and quenched and formed a glass. Then I done the glasses I prepared a ball milling by using ball milling technique. I prepared a nano powders of the glasses, and then I went for Xrd and DT analysis. From DT analysis, we came to know that what is glass transition temperature, what is crystalline temperature, what is melting point temperature. So in between glass transition temperature and actually in between glass transition temperature and crystalline temperature, we heat that glass powder. Okay, so while heating that glass powder, so what happened means some grains will develop in the glass network. So these grains acts as an active centers, acts as conductive centers in that entire network, so that we can boost our conductivity which is drawback for the sodium ion battery. So that we are doing glass first, then we are converting that glass into glass ceramic to boost the conductivity of that network which is present in the glass. So then I prepared an active material there. I was coated and synthesis glass, sodium foil, and coin cell in my laboratory, and then I was tested by using new battery testing device. So this is my anode network. So I was already told you that I went for DT and Xrd result. So I got a glass transition temperature and a glass crystalline temperature for all my samples, and then I went for Xrd analysis also. So in this Xrd analysis, we have seen a amorphous phase was there for glass. Then while heating 5 hours, 10 hours, 15 hours, 20 hours continuously, then there was a growth in some crystalline phases in that glass network. Some phases for there is a growth of some phases in that glass network. So what was that phases is this V2 ZnO4 Na2 ZnO2 and NaVO3. These three phases that I have seen in my glass network after heat treatment. So these are the different phases, and that phases has monoclinic structure. One phase has cubic structure. One phase has monoclinic structure. I will say that what is the role of these phases in my glass network. Why these phases are suitable for me. I will explain you in next analysis. So later I went for SEM analysis. So these SEM analysis we have seen for glass samples which is inserted. These are the glass molecules, glass samples. So after heat treatment, we have seen clearly some grains are grown in this glass network, which we call as glass ceramics. Then after these structural studies and microstructural analysis, I went for electrochemical analysis to check my battery capacity and potential. And
Are you going to fabricate it practically?
yeah, sir, I have fabricated it. See, I have see here. I was fabricating this thing in my lab.
So in which stage is the project now?
Actually, I have designed one cathode material, one anode material, sir.
Okay.
And I am planning to design an electrolyte.
So
Now,
is it sufficient for PhD work?
sir.
Is it sufficient for you can say conventional PhD work?
Yes, sir, because I am designing a complete cell at different temperatures. We know that normally at the room temperature we have seen coin cells or batteries, but while coming in practicality, we need to check it at high temperature because the working batteries, like if you in an electrical vehicle, so it is working at maybe at a 60 degrees, 70 degrees temperature. So there is a drawback that at that temperature the battery may not be sustained because of that high temperature. There is fire catching things we have seen. So to overcome this, I was checking my battery condition even at above room temperatures, even at 60 degrees centigrade. So and these sodium ion batteries are new to uh, this scientific society. So I'm coming with a new system. However, so then coming to my electrochemical analysis. I have plot a different for all my compositions like a sodium varying with mole percentage, and then I went for impedance spectroscopy also. So here we can see for black and Z zinc 20 more percentage showing high conductivity when compared to remaining compositions. So for Zn20, I have went for different cycles, like up to 500 cycles I have gone through. Like there is no much loss in that capacity and even in potential also. So that then this is for glass network. This electrochemical analysis is for glass network. So later I went for glass ceramics. If at I have told you like glass and glass ceramic I'm preparing. So when I compared with the glass ceramics, the same analysis I done with the glass ceramic, and I went up to 3,000 cycles, sir. 3,000 cycles means like we can easily say like if we adopt this thing to our mobile phone, up to 5 years we can easily work without loss. So up to 3,000 cycles I went for glass ceramics. Here I can show you the entire details of that. For glass materials, the Coulombic efficiency is maximum we got 97% Coulombic efficiency, and even after 500 cycles, so we got 278 milliampere per gram discharge capacity. But for glass ceramics, we got 98% efficiency, sir. And
Is it
highest,
possible? Is it possible to get 98% efficiency?
yes, sir, definitely.
Okay.
Yes, sir. Uh, I will say why it is exhibiting best. There is some chemistry behind it, sir. Like I will let you know.
Okay.
Then it's showing 383 milliampere hour per gram, which is good when compared to like existing carbon and graphite based batteries. Also, it is highest capacity, sir. Like I was compared this with graphene and carbon based coin shells also. The carbon based and graphene exhibits like around 280 to 90 milliamperes per gram capacity, so which is more than that. Then here uh, later I have after getting this highest capacity, like what is the reason why I'm getting this much high efficient stable network. So later, after having this analysis, sir, after completion of all these life cycle analysis, all this electrochemical analysis, again I went for a um, uh, some structural properties, structural characterizations like XRD and chem and SEM analysis after my cycles completion. So I noticed that there is a replacement of this vanadium plus state in the glass network by Zn2 phase, and it forming Na2 Zn O2 phase totally. I was when I at initial I have showed you three phases was present in XRD. Later, when it was charging, while charging, the sodium ion will come to the anode network. So when sodium ion is coming to the anode network, what happened? This which was already formed with VO2 vanadium oxide phase. That vanadium oxide phase, due to this sodium is diffusing with that, this vanadium is replacing with Zn plus and forming Na2 Zn O2. First it is I will show here, you can see that clearly,
How many slides are there, Krishna?
sir.
How many more slides are there?
Going to complete, sir. Just conclusion left. So I have calculated the diffusion coefficient also for my battery. So due to this diffusion thing, we got a high stable, conductive phases, sir. Then, so from this, I'm concluding that the voltage of my anode material is around 3.48, which is relatively good, and which is same for the lithium ions also, like and charge capacity and discharge capacity, which is more than a carbon and a graphene capacity range, and good Coulombic efficiency, and high energy density is also around 0.18 per gram. If you integrate these two for kh, we get around 180 volt hour, which is relatively good. And life cycles we went up to 3,000, and we this thing what I showed you is operated at 45 degrees, but there later we have gone through 60 degrees also. Like I will go for next publication according that results. Thank you so much, sir.
Thank you, Krishna. I think you are prepared well and you are doing a good research work. When you are supposed to submit your thesis?
Maybe by this January, sir. By this month.
January 2023, right?
Yeah, yeah, sir.
Okay, 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 Krishna. Best of luck.
Thank you so much.
Uh, and for this conference, you will get the certificates and the proceeding in the coming week.
Okay, okay, sir. Thank
Okay.
you so
Okay.
much.
Thank you, Krishna.
Thank you so much.
Okay.